Alright, hello up there. Um, just going to go over here a little bit of nomenclature. Okay, it's a fancy word for naming stuff. So, we're going to name, well, here, it's just going to be me going through a few examples basically. So, got a couple of names. I'm going to look at how I think about what that molecule is and draw out the formula. And in the first case, it asked me for a displayed formula. So I'm going to be making sure that I draw every single covalent bond. And then at the end here, we're also going to look at how to, from a formula, from these structural formulas, from those structural formulas, how to name something systematically. Okay. Now, nomenclature is a massive bit part. Say part of the course. It's only a couple of small lines in the spec, but it comes up again and again because organic chemistry is a huge part of the A-level course. And naming things where you need to be able to name pretty much anything in the course. So once they've said that you need to be able to name everything in the course, then suddenly you've got a huge amount of rules that you actually need to learn. And the nice thing is you just kind of soak them up as they come. By the end of the A-level course, you will be pretty good at naming compounds, actually. It's a nice, systematic way of naming things that they get you to do. It's quite satisfying when you get used to it. But when you look at a name sometimes, like this top guy, you think, oh, what's going on there? You've got all these commas and hyphens. And very simply, a comma first, the numbers tell you which carbon atom you've got things on. So if I'm going to draw this out, I'm going to think, okay, first ethane. My whole thing is based on ethane. So let's draw out 2 carbons because ethane has 2 carbons. Let's not put in the hydrogens yet because I know I've got loads of other stuff to substitute some hydrogens off and put on for. So I've got some chlorine atoms. A chloro group tells you chlorine atoms are coming off. The 1 and the 1 and the 2 tell me that on which carbons I have a chlorine atom. And the tri tells me that I have 3 in total, which is nice, which matches the fact I have 3 numbers, 1, 1, 2. So if you've got a tri, always look in front of it. You should have 3 numbers every time you see a tri, because each number tells you on what carbon each chlorine is on. So let's make the left-hand side carbon number 1, and let's put 1 carbon on, 1 chlorine on, and then, oh, it's got another chlorine on, that second one. And then the third chlorine is on the 2, so let's put it on the right-hand side, number 2 carbon. Okay, so I've just numbered my carbons 1 and 2 from one end. Now, it doesn't matter which end I number them from here because I'm making up the whole thing from the name. So if I'd done it the other way around, I'd just get the same molecule but flipped over. So what else have I got here? Well, I've got a fluoro group. Now, fluoro groups are just fluorine atoms. Again, trifluoro, I'm going to put 3 in total. But now this time I've got 1 on the 1 carbon. And then I've got 2 on the second carbon. 2, 2 shows me I've got 1 on the second carbon, and the second 2 tells me I've got a second 1 on the second carbon. So, and now I just fill in and put the hydrogens in, but I don't need to put any hydrogens in now because it's been such a busy molecule that it's used up all the bonds to carbon already. So just made formula of 1, 1, 2 trichloro, 1, 2, 2 trifluoroethane is just that I've got below. Another thing to note is, well, they chose in the name to put the chloro, talk about the chloro stuff before the fluoro stuff, even though chlorine's a bigger atom. You know, why did they choose to do that? Have a little think. It's actually because the alphabet, and this is the bit that really gets me. It's the alpha, so I need to know whether C or F is which one's first in the alphabet. Anybody who's got taught by me before will know that that's a bit of a struggle for me, but I just about managed to keep my head above water because I think C is before F in the alphabet, and that's why we're going to mention the chloro things on the ethane before the fluoro things. So actually alphabetical, when you've got loads and loads of groups and you have to decide how to put them into a name, if they're both things that come at the front of a name called a prefix, like these fluoro and chloro groups are, then I'm going to have to decide to put the chloro ones before the fluoro ones because of the alphabet. Okay, so, and you see, just one example there. I've mentioned quite a few things actually. This is just the minefield that nomenclature is, but you'll pick it up. 4-hydroxypentuene. Okay, again, if I'm going to draw something from a name, I'm going to start on that parent chain, we call it. Okay, and it's the pent. So pent. Now here they haven't asked me to do a displayed formula or anything. So which type of formula am I going to do? Skeletal formula, if you listen to my last video at all, because it's easier. So pent, 1, 2, 3, 4 lines, we'll join 5 carbons. 1, 2, 3, 4, 5. Okay. On the second carbon, this guy, there's an alkene bond. Now, well, does that mean my alkene goes between the second and the first carbon, or between the second and the third carbon? Now, it has to go between the second and the third carbon, because IUPAC, these are guys that make up all the rules. Okay, anybody who likes rules, go and work for IUPAC. You'll have a happy life. Anyone who... these guys make up the rules, and they said that you've got to use the smallest number as possible, as small numbers as possible in your name. So here, come on, draw a line. Draw a line. Sorry. I'm going to kick off. What's happening? What is wrong with my computer? This guy. Draw a line. Draw a line. There we go. So put the alkene between the second and the third carbon, because if, let's try a different colour, if it was between the first and the second, well, actually, we wouldn't choose the 2 number to put in the name. We'd choose the 1 number, because 1 and 2, well, 1 is a small number in the whole IUPAC naming thing, so we use the smallest number when we can. Okay, so the pentuene tells me I'm going to put that double bond between the second and the third carbon. Everything else is just boring carbons and hydrogens. The nice thing about skeletal is that I don't need to worry about drawing them in. But for hydroxy, well, on the 4th carbon, then I need to put a hydroxy group. So count along: 1, 2, 3, 4. That one, I need a hydroxy group. Now, go away. What is a hydroxy group? So, if I don't draw with the rubber. A hydroxy group is actually an alcohol group. Hydroxy, why have they used hydroxy and not just called it pentanol? Well, because our ene was a suffix already, i.e. at the end of the name, then if we've got a chance to use a prefix, i.e. something at the start of a name, then we do. And alcohols have the choice of having a suffix ol or prefix hydroxy. So when you've got another thing that's got the suffix, like the alkene, then you're going to just decide to call it hydroxy at the start, rather than having 2 suffixes. It's a bit hard to end a name. You can do it. You could call this pentuene for ol, but if you don't have another prefix, then just whack the hydroxy prefix in there, because it's nice to have 1 prefix and 1 suffix. Okay, so that's kind of drawing names from drawing compounds from names. Well, here's how to name something from a structural formula. Now, first of all, I would always roll this formula out differently, because structural formula is supposed to be written in paragraphs and things, but it doesn't really jump out at you about what this structure is. So we've got CH3 is 2, so 2 CH3s are linked to that next carbon. So that carbon has 2 CH3s coming off it, and then then a hydrogen, which I don't draw because I can do skeletal, to a next carbon, which has got a hydrogen, don't draw, but this carbon also has an OH on it. So this carbon that I've drawn here has an OH, so draw that OH, and a CH3, so the CH3 is just a line going to nowhere. And now, because I've got things sticking off a chain a bit more, then it's a bit easier to do my naming. Now, naming involves getting the longest uninterrupted carbon chain. So here, there it could be 1, 2, 3, 4. Or actually, you could have decided to go for 1, 2, 3, 4. Both would have 4 in total. Now, actually, I'm going to name it both with the pink and then the blue, and you'll see that the name is exactly the same. Now, once we've got that chain, so let's imagine we're using the purple chain. So if I just undo once to get rid of the blue one, if we imagine using the purple chain, that's the parent chain. That everything within that chain has meant that we're going to, the middle of the name is going to be bute, because there's 4 carbons. Now, I need to first of all think of what each one of my group is. So I have a group here and a group here. Well, this group is a methyl group, this top one, and this group is an alcohol group. Okay, so methyl is only a suffix. I don't know. Sorry, it's only a prefix, the start of a word. There is no suffix particularly. for a methyl group. So that fits in very nicely because alcohol has a prefix and a suffix, so I can choose to use the ol, the suffix, which is actually better anyway. So I'm going to put a methyl and an alcohol in here, and the last thing I need to remember is the numbers. Okay, so the numbers here, 1, 2, 3, 4, counting from the left, I'm going to have something on the second and something on the third. If I count from the right, 1, 2, 3, 4, I've got something on the second and something from the third. Now, normally they won't give you an example where you have to make a choice about which is more important, but actually the OH is a more important group, and there is a massive priority list that technically AQA do need you to learn, but in practice it's too much, and you wouldn't. But you do have an idea of things that are high priority are things like alcohols compared to a methyl. Methyl is a very low priority because methyl groups don't really react, and the carbon atom probably has high proton number and things, and in terms of numbers of heteroatoms and things. So the OH is higher priority. So we're going to number 1, 2 to try and 3, 4 to try and get the number down on that OH. Okay. Now, pretty sure AQA would allow you to do the numbering either way. Actually, I think that would be pretty harsh of them to penalise you for that, but you never know. They sometimes do expect quite a good standard of this. So that means that on the 2 we have the ol, so it's butan because it's no alkenes, butan 2-ol, and we've got that methyl sticking off the third carbon, so it's 3-methyl butan 2-ol. Now the 3 and the methyl needs a hyphen between them because we have a hyphen between every number and letter. We don't have a space between the methyl and the butan. They just go together. Okay, I know I wanted to leave a space there. Don't have a space. There's no space. Link them together unless you know there's not a space. Okay, and then in some cases there isn't a space. So again, there's a lot of things to learn with this nomenclature. And then there's hyphens between the N and the 2 because it's number and letter, and the 2 and the O because again it's number and letter. So hyphens in there as well. How we doing for time on this, guys? It's getting a bit of a long video already, but if you want to see me go through this example, then feel free. So let's do this one as well. I'm going to do a skeletal there, CH3, CH2. So that's the first 3 carbons because I've got left, middle, right. Now that right carbon there is the third along, and that's the one that has a CH3 sticking off and a double bond to the carbon that has 2 hydrogens on. So actually skeletally that's all it is. In terms of naming, and I apologize, I just realised that on the last one I didn't go back and do the blue chain. If you go back and do the blue chain, actually just very quickly, blue, 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 it's actually exactly the same name because on the second I've got an alcohol group, and on the third here I've got this thing which used to be in the chain but not in my purple group, but now that I'm naming it the blue way, it's not in the chain but it's a methyl group coming off the third. Okay, so you see how the name is exactly the same no matter which of the longest chains I use. In this case there is a very important place, the bottom case, there's a very important point which I need to keep the alkene bond in my chain. Okay, I need to keep the alkene bond in the chain to keep the naming simple because then it's just an ene rather than having some like extra group that happens to be the ene sticking off the side, and naming gets very complicated there. So we keep the alkene within the parent chain. So it's 1, 2, 3, 4 long. I'm going to number from which side? The right hand side, because that means that I'll have an alkene on between the first and the second, therefore I'm going to call it a 1-ene, and I will have a methyl group on the second, and I have nothing on the third and the fourth, so it keeps the numbers down. So it's based on butene, it's based on but-1-ene, and it's a methyl on the second. So this is going to be 2-methyl. That says methyl. But, no space. But 1-ene, but 1-ene. You say but-1-ene, but you don't draw the ene twice. That e from ene goes after the number that tells you where the ene alkene is. Okay, so it's 2-methyl but-1-ene for that one. Okay, lots more examples for you to have a go in the worksheet that's we mentioned on Teams.